Welcome to our next lecture of metrology and instrumentation, as we have already completed our unit 1. So we are entering into our unit 2, which is comparators. So in this we have to discuss about various types of comparators which are working based upon mechanical, either it is based upon pneumatic technique or either it is based upon other techniques. Okay, so let us see what is first comparator. A comparator is nothing but a precise instrumentation which is used to determine the dimensions of a component. For example, in previous first unit we have discussed like linear measurements and angular measurements. In that we have seen various types of devices like vernier calipers, micrometers, height gauge, depth gauge. In angular measurement we have seen like a autocolorimeter, laser colorimeter, either it may be angle gauges. So different type of devices we have seen. So during for measurement of these devices, when we are trying to make these devices, we should use some kind of particular what we say standards. So for that we generally go for comparator. A comparator is nothing but a precise instrumentation which is used to compare the dimensions of a given component with some standards, especially like slip gauges. So it does not measure the actual dimension, but indicates how much it has been differed from the basic dimensions. For example, your dimension is like 40 mm. So if you see this, either it can be we can use this comparators either to measure circular dimensions or linear dimensions. So when the comparator is trying to deviate from the original position from the basic dimensions, so by what deviation it has been acquired from basic dimension, that we can measure. So in mass production, identical component parts are produced in a large scale. So for measuring of large scale, we cannot use micrometers, vernier calipers, because we cannot take each and every object, we cannot see them. So in such kind we can use comparators for measurement. Generally the comparators have been classified as these 6 types. Among these 6 types we can see that the basing upon the type of device or type of mechanism which we are generally using for the working of comparator, we have divided into 6 types. One is mechanical comparators, for second is pneumatic comparators, third is optical comparators, fourth is electrical comparators, fifth is electronic comparators, next is combined comparators. The first is mechanical comparators. So in this, the main mechanism which basing on which the comparator is working is the usage of gears, pins, linkages, levers, springs. So these are the devices generally which we use for the mechanism or by which the comparator is going to work. Whereas in pneumatic we use some kind of high pressure air valves. Pneumatic, when I say hydraulic means liquid, pneumatic means air. Most of the time we use air valves here. We doesn't use most. There are other liquid comparators also there, but liquid comparators mostly we don't use. So most of the time we generally go for pneumatic comparator itself. Next is optical comparators. In this, mirrors, lights are used. Optical means light. So by the use of light and sense lenses, we generally use this comparator. The mechanism is completely based upon this. Next is electrical comparators. In this we generally use electrical things like step up, step down, transformers are generally used. Whereas in electronics we use some amplifiers, digital signals, etc. Combined comparators are nothing but we use any 2 of this or 3 of this. We generally combine mechanical pneumatic, optical pneumatic, electrical electronics. So combining among the 5 which are above, so that is called as combined comparators. So basing upon these, the first thing which we are discussing is mechanical comparators. So among the mechanical comparators we have divided into, again there are 4 different types in which 4 different mechanisms are being used in comparator. The first one is dial indicator, second is rate type comparators, next is sigma comparators, and Johansson Microkator comparator. So in dial gauge indicator, generally it operates on the principle that a very slight upward pressure is acting upon a spindle at the contact point is multiplied through a system of gears and levers. So generally what is comparator is nothing but this. So it is in dial indicator we will be having a dial on which there will be a different type of divisions. So there will these divisions to that divisions we will be connecting same like your watch. So first thing what we do in this, this is the dial gauge, this is a plunger. So what we do to the plunger is we generally press the plunger and place on the device. For example, I want to measure the surface roughness of the device. So I will try to press some little pressure is given to the plunger and try to keep the plunger on the surface. After placing on the surface, I will try to make the reading 0. Once it is placed on the surface, then only we will make the reading 0. So then after that, what we will try to do is we will try to move the dial indicators on the surface. So to what length we have to measure the surface roughness, or to what dimensions we have to measure its finish, to that length we will try to move the dial gauge. So when you are moving the dial gauge, if there is some any deviation, so what happens to the plunger is either the plunger will be released or plunger will be pressed. When it will be released is when the surface, when you got some depth on the surface, and when you suddenly get some hollow thing on the surface, the plunger will be released, because while placing on the surface you have given some pressure. So because of presence of hole, the pressure will be released and it will be removed. So when it still try to move on the surface, because of the hub or because of the crust or trough, what happens to the plunger is the plunger will be pressed. So when it is pressing and releasing, so here we are having a rack and pinion mechanism. So what is happening to the rack and pinion mechanism? When it tries to move up, the gear will be rotated. So by the rotation of this, what we try to do is the dial gauge will be rotated by the rotation of this wheels, or that is nothing but the pinions. We are giving that pinion rotation to your dial indicator. So that is nothing but your what needle, which is present to show the deviations. So okay, so for example, you are getting a deviation like 0 to 40 means it is huge deviation. If you are getting 0 to 10, it is acceptable deviation. Once you are done with the operation, you want to reset, there will be a cap where you can press that and you can reset the deviations. Okay, so for example, once the plunger is pressed, again it has to retrace. When it is pressed, again the pressure has to be retraced. For that retracking, we have a spring here. So that spring will be compressed when pressure is given. When pressure is released, that will be releasing the plunger. Okay, so it is indicated on the face of the dial gauge by a dial finger. So the dial indicator basically consists of a body with a round graduated dial and a contact point connected with the spiral or gear train. So the hand of the dial gauge indicates the amount of movement of the contact point. The indicator is set to 0 by using of slip gauge representing the basics part of the size. So this is, in this way we can use when we are turning some part on lathe machine, when you are holding it on the headstock. So if you want to check the surface is having a smooth surface or rough surface, we can able to have a dial gauge like this. We can move the dial gauge along the surface. Okay, so you can able to find the deviation. Similarly here also, when you are cutting some surface, you can able to find the surface roughness of the cutter. Similarly, when you are rotating some pin, so for that pin, if you want to find the exactly how circular the object is, for finding the circularity also we can able to use a dial gauge. Okay, so applications: comparing the two heights or distances between the narrow limits, so that to determine the errors in geometrical forms such as that's what I have told. Circularity can be found, ovality, roundness, taperness can be measured. For taking accurate measurements of deformation such as intensity of compression. Okay, to check the alignment of lathe center, how the lathe centers has been placed between the two jobs or between a job, that can be measured. To check the trueness of a milling machine arbor, for example, arbor is rotating between a milling machine which is carrying your tool in a milling machine. So either it is parallel or not. How we can measure is we can keep a dial gauge on the arbor and we can move that dial gauge along the arbor from the start to the end. So if there is no deviations in the dial gauge, you can say that it is parallel. If it is getting deviation, that means it is having some deviations at some point. So we can able to rectify the deviations. Next is Johansson Microkator. So it is based upon the principle of button spring. So this is like this. So in this, what is happening is when the plunger is plus, similar thing. Okay, only thing is that one side is fixed, another side is like this. So because of this is the pointer which is being connected. So these are the twisted metal strings. Okay, which will be just like work as a spring. Okay, when your plunger is connected, here you can see that here you have a pivot joint, and this let me show you clearly. Sorry. See this is a pivot joint on which a L shape or a fixed frame is being created, which is in the shape of a L, and this is the anglet which is provided here. When the plunger moves above, you can see that because this is a fixed L shaped joint, this moves up. As it moves up, it goes back. So as it goes back, what happens means this will try to rotate this will try to move the scale. So there is nothing but pointer. So that pointer, when it is moved, you can observe the readings on the scale. Okay, so when it is getting reflected back, this twisted spring will try to push back. Once it is completed, it will try to push back so that your plunger comes back. Okay, clear? So now let us see how it is being worked. It works on a principle of button spring, that is nothing but spinning of a loop of strings. Like you can have seen a child's toy in which you give the key to the toy. When you are giving continuous key to the toy, after you release that key, the toy will try to run. Similarly, when this will also work in the same way. So when it is being turned, when it is being moved forward, so the turns will be keep on rotated. So once your work is done, this motion is completed. Once it is completely moved down, it is stopped at some point. Once it is stopped, to what turns it has been twisted, so that will be released back. Okay, just like you can use in your homes also, there will be a swinging this. When you rotate that continuously, when you are leaving it will try to unrotate itself, it will try to release itself. Similarly, that this will be working. The method of mechanism magnification is shown in the figure. It is employed at twisted metal strip. Any pull on the string causes the center of the strip to rotate. Okay, as a little pointer made of glass tube is attached to the center of the twisted metal strip, the measuring plunger is on the slit washer and it transmits its motion through the bell crank level, the twisted metal strip. Bell crank level is nothing but that L shape. So the other end of the twisted metal strip is fastened to the cantilever strip. Because it is fixed, so that is cantilever. The overhanging length of the cantilever strip can be varied to adjust the magnification of the instrumentation. The longer the length of the cantilever, the more it will be deflects under the pull of the twisted metal strip. Unless rotations of the pillar is pointed, means you can able to see minute changes also if the length of this twisted strip is longer one. Okay, so next is reed type mechanical comparator. So in this, the reed type is reed mechanism is a frictionless device for magnifying small motions of a spindle. It consists of a fixed block which rigidly fastened to the gauge head case. The floating block B block carries the guiding spindle and is connected to horizontally to a fixed. So here it is. So this is like this, A, B, C. So this is fixed. So whereas this can move up and down. So this is not fixed. Okay, A is your fixed position. B and C and B are your positions where basing on which your pointer will be deviating. When it moves up, so because of the motion of this, so it will try to move up. Because of this is again a pivot joint. The pointer will try to show the dial gauge indicator. That means it will show the dimensions. So the reed mechanism is a frictionless device for magnifying the small motions of the spindle. It consists of a fixed block where A is fixed, which is rigidly fastened to the gauge head case. The floating block B carries a gauging spindle and is connected to horizontally to a fixed block by reed C. So the vertical reed is attached to each block with the upper ends joined together as shown in the figure. Beyond this joint, the extended pointers are target. A linear motion of the spindle moves the free block vertically and causes the vertical reed to slide. Here what is happening? So when it is being moved, so the spindle is trying to move this whole block. So when it is trying to move, because of this motion, this which is fixed, it is fixed to this block, it is being trying to move along this. So when it is getting deviated, which is connected to the horizontal reed, that is nothing but this vertical reed or the pointer. So this vertical position is converted to horizontal position, and because of this pointer is getting deviated. That is nothing but linear motions are being converted to rotatory motion here. Okay, the movement causes the pointer or the target to swing through an arc over the scale proportion to the distance traveled with the spindle, and of course very much magnified. The comparator of this type may have a sensitivity of 0.25 micron per scale division, means almost like 0.25 mu, means 10 to the power of minus 6 you can able to measure. So the small displacement here can give you a small deviation in the pointer. Okay, so this is the same, all these are working on the same principle. This is your surface where the plunger is going to touch. When the plunger gets some deviation, it gets either pressed or either it gets releases. When it is pressed, so it will try to move up. So when it is trying to move up, it will be trying to move up. See this, since this is fixed, so it cannot able to move, but whereas this is free, so it will try to move above. So when it is trying to move above, it will try to push this wall, push this wall. One wall is fixed, other side other wall is free. So when it is trying to push from here, the pointer will move in the opposite direction, it will move in this direction. When you are releasing this, when you are trying to release in this direction, the pointer will try to move in this direction. Okay, so this is the principle of real type of mechanical comparator. Next is mechanical optical comparator. In this mechanical optical comparator, the small variations in the plunger movement is magnified first by a mechanical system, then by optical system. Means here, if you, for example, if you see here, we have taken three set of combinations, like a couple is being taken here, where the pivot joint is kept at a distance of one position x1 and other position it is being kept at x2. So because of this distance, smaller distance to bigger distance, we can see that we have been magnifying this. For example, if you get a small deviation here, it will be obviously multiplied here because of the largeness of the length. Okay, so the couple has to be fixed, clockwise direction and anti-clockwise direction should be fixed. So this plunger, when it is trying to move on the workpiece, it will try to either move up or down. So because of that up or down, so this plunger will be trying to move up or down. Now again this plunger has been connected to a mirror, so because of the motion of this mirror will be trying to move up or down. Okay, clear? I might be clear very clearly to you. So if I move here, so the mirror will be moving down. If I move down here, the mirror will be moving up. So because of that, what we are doing is we are having a light source here which is passing light. When it is at a stationary position, initial position, will be having a screen where you can get the image properly. So when you suddenly when suddenly some deviation comes here, what happens here is nothing but the mirror will be either tilted by some angle, either by moving upward or downward. Because of that, the angle will be deviated like this, the image will be moved like this. Okay, so that variation which we have obtained in the image, that we can able to observe and we can able to analyze that how the variations are being achieved. Okay, so in mechanical operator, how it generally works is nothing but a small displacement of the measuring plunger are amplified first. How we are amplifying, where we have pivoted here, because of that it is getting amplified. So the amplified mechanical movement is further amplified by a simple optical system involving the projection of angles. So here also, if you see this, here the small x, that is nothing but again this is pivoted here. So because of the motion of this is getting deviated. So this small deviation is creating a what is happening to the image is getting deviated a lot. So image will be getting deviated. So there will be a formula like this. So the mechanical amplification is nothing but x2 by x1, optical amplification is nothing but x4 by x3. But whereas single amplification in this will be getting twice the amplification in optical. So that's why we multiply generally by 2. So it is multiplied by 2 because if the mirror is tilted by theta, then the image will be multiplied by 2 theta. Okay, thus the overall magnification is equal to x2 by x1 into x4 by x3. So this x4 by x3 into 2 is there, so this is obtained here. Clear? So the mechanical system causes a plane reflector to tilt at both an axis. Okay, and the image of the indexing is also projected on the scale of the inner surface of the ground glass screen. The optical amplification provides a high degree of measuring precision. So by using the optical variations, we can able to measure to much precise values. Precise values means we can able to measure for small ranges also. Okay, so what is the advantage of optical comparator is nothing but it has small number of moving parts and hence high accuracy can be obtained. So if you see in previously, there are in more number of moving parts. Because of that, the moving parts, if they get worn out or if they get any jam together because of continuous motion, because we know in all the mechanical devices, if they are continuously used, there will be some kind of worn out, or there may be some kind of, because of rusting they may get jam. So you have to keep on rectifying all those things. But whereas in optical there is no such kind of thing will be present, because we are completely using a light source. In the optical comparator, the scale can be made to move past a datum line. So we can be able to move the datum line from one place to other place. Thus a high range and no parallax error can be obtained. It has very high magnification, yes, because of the optical magnification we can able to achieve high magnifications. Optical lever is weightless. Next, sigma comparator. The sigma comparator also same purpose here. Here we are having a knife edge thing here. So when the plunger is being moved, what happens to this knife edge, since it is sitting exactly here, when it moves above, so this this will try to this knob and this, which are exactly sitting together, it will not be sitting. So this will be moving forward. So this is nothing but it is moving a particular length L. So when it moves forward, it will try to push this. So when this block is pushed, this block pushing will be trying to push the pointer on this. Okay. So one fixed to other, because of that you can able to move. So see this will be like this. So this part. Okay, fixed block, movable blocks like this. Okay. So this is your movable block, this is your fixed block. When you are trying to move this, so because of this fixed block will also be moving, this fixed block will try to pull this or push this. When it is being pulled or pushed, so that linear motion is converted to a rotatory motion of the pointer. Okay. So let us see how it is being worked. So the plunger is attached to the bar, which is subjected between the bending plates at the top and the bottom as shown in the figure. The bar is restricted to move in a vertical direction. A knife edge is fixed to the bar. The knife edge is attached to the sphere plate, which is attached to the moving block. So this is sphere plate. Okay. So this is sphere plate on which it can able to move, slide easily. Okay. So the knife edge exerts a force on the moving block through sphere plate. The moving block is moved to the fixed block with the help of the crisped strips as shown in the figure. This is your crisp strip. Okay, this is your crisp strip, because of which it is moving. So when the force is applied on the moving block, it will give the angular deviation. So the Y arm, which is attached to the moving block, transmits the rotatory motion to the driving drum of radius R. This deflects the pointer and then the reading is noted. What is the advantages of mechanical comparators? They do not require any external sources of energy. Like in optical, we need some kind of sources of light. Electricity is needed. These are cheaper and portable. This can be used at any position, same as daily also. These are robust construction and compact design. So if you see comparing to that of a dial gauge indicator, or either it is like a Johansson Microkator, or either it is for like previous one, that is nothing but your optical comparator. This is having much complex structure where you have to use only a knife edge type of device, and here it should be V point has to be kept. Because this is a knife edge, it may be easily worn out when you are applying lot more pressure on this. So this knife edge can be easily broken. So this is a simple mechanism, but whereas there are few drawbacks also. Okay. Next disadvantage, the range is limited as the pointer moves over a fixed scale. The pointer scale system used can cause parallax error. There is no magnification. So there are a number of moving parts which create problem. That pin I have told, that is the biggest problem. Since they are in direct contact, there will be a friction which is generated in this. Ultimately the accuracy will be less. This instrument may become sensitive to vibrations due to high inertia. Yes, because of vibrations it can able to read easily. Next is pneumatic comparators. In pneumatic comparators, generally it works on the principle of pressure difference of air. So air is supplied at a constant pressure through orifice. Okay. So and this air escapes in the form of jet through the restricted space, which exerts an back pressure. So the variation in the back pressure is used to find the dimensions of comparator. Okay. So see this. This is your manometer. This is your water tank in which water is filled. This is a compressor where air will be compressed and it will be sent through a filter when you are passing the air through this, what happens through the orifice. So because of the orifice, it will try to create the pressure on this. So the back pressure is created, because of it the water level will be increased. This difference is generated by using a manometer. Because of this difference, it will, because as this is exposed to the open air or escaping air, so the extra air which is trying to escape, it will try to push this plunger forward or backward. For example, you can see here A1, A2. So this is the air direction. When the air is coming inside, the plunger will be moving. That is nothing but it is rotating in a clockwise direction or whatever it may be. So since the position is A2 to A3 or A4, so basing upon the position, you can see working principle here. The excess air escaping in the form of bubbles, then the metric amount of air is passed through the orifice at a constant pressure. Due to restricted area at position A1, the back pressure is generated by the head of the water displaced in the manometer tube. To determine the roughness of the job is rotated, okay, along the jet axis. If no variations in the pressure reading is obtained, then we can say the job is perfectly circular or position A. So then the same procedure is repeated at various positions like A2, A3, A4 positions, and variations in the pressure reading is found out. Also, the diameter is measured at position A1 corresponding to the proportion against the two jets, and diameter is also measured at various positions along the bore. Okay. So with this we will try to stop, and we will try to continue in our next lecture. Okay. Thank you.